Hello again, everyone. Mr. Cruze here with another geometry review for you. This time, the Chapter 12 review, which is all about circles. Alright? In these videos, I'll be helping you prepare for your test, which is tomorrow, Tuesday, May 21st. As always, you can always email me, ccruze@brownsburg.k12.in.us. You can tweet me at Mr. Cruze Math, or you can always come in for extra help in the morning if you're not sure about what to do. Alright? If my feelings are, if you can do this review, you should be just fine for the test tomorrow, okay? Number 1 says, in the following diagrams, find the value of x. Lines that appear to be tangent are tangents. So let's review something about tangents. First off, they're a line which only touches a circle in one and only one point, called the point of tangency, okay? They're really kind of special. You can also have tangent segments as well. But anyway, they are perpendicular to the radius at that point. Perpendicular. Maybe I should draw that in red so you can see that. Perpendicular. Okay, so they make some right angles, which means when we look at one here, those are right angles. And then I happen to see this kite. I know it's kite for various reasons, but I see this quadrilateral basically, and all four angles have to add up to 180. So that means 90 plus 35 plus 90 plus x has to equal 360, because the angles in a quadrilateral add up to 360. Okay, that's 215 plus x equals 360. You subtract 215 over and you get x equals 145 degrees. Okay. Example 2, again we have a tangent. But this time you have a triangle, and we know that the angles in a triangle add up to 180. So since this is 90 of it, that means x plus 36 has to add up to the other 90 of the 180, which means when you subtract 36, x ends up being 54 degrees. Very simple problems. They don't take you very long. Okay. Determine whether the segment is a tangent. Well, in order for it to be a tangent, I know it kind of looks like it, but you'll notice this time they don't say assume lines that look tangent are tangent. In order to make this a tangent, wouldn't this have to be a right angle? Okay, and the only way I can be certain of that is thanks to our good friend, the Pythagorean Theorem. If Pythagorean Theorem holds true, if a squared plus b squared does in fact equal c squared, then boom, we've got a right triangle, and we know that that segment is a tangent. So let's see. Literally c. Remember, c is always the longest side. So we have 7 squared plus 15 squared. And I'm going to put an equal with a question mark because we're not sure if it exactly equals 16 squared or not. 7 squared is 49. 15 squared is 225. And 16 squared is 256. Well, 49 plus 225 happens to equal 274. Does that equal 256? Nope. So this is not tangent. And if they were to ask you to explain why, it's because a squared plus b squared does not equal c squared. Not tangent. There's going to be a lot of Pythagorean theorem on this test, alright? Told you triangles would come back. Number 3, determine whether the segment is a tangent. Well, this is kind of a little bit different. Again, this would need to be a right angle, right? We have a triangle with two angles, 61 and 29. Well, I know, we might as well call that x. I know that those three angles together have to add up to 180 degrees, right? Well, 61 plus 29 happens to equal 90. And when I subtract 90 from both sides, x has to be 90, which means, yes, it is tangent because it makes a right angle. What do you think? Not too bad. I think it takes longer to write out the answer than it does to get the answer. Okay, find the value of x to the nearest tenth. Well, hey, look, we have a right triangle with some missing sides. So I can have a squared, b squared, and this whole thing is c. Now, a squared would be x squared. B squared would be 8 squared. But let's think about what c squared would be. C is 5 plus x. It's the whole segment, right? We remember segment addition. This is x and this is 5. So together they are x plus 5. Okay. Now this is where you have to remember something from Algebra 1. X plus 5 squared is actually x plus 5 times x plus 5. you have to do something called FOIL, or it's really distributive property. But basically, you take x times x, that gives you x squared. You can take x times 5, that gives you 5x. You can take 5 times x, that gets you another 5x. And you can take 5 times 5, which gives you 25. I did the colors so that you can see what goes with what. Hopefully you remember my smiley face, right? My big ears, my big eyebrows, my double chin, right? These are ways to remember how to FOIL. Okay, you can make the face. Anyway, we can simplify this a little bit. So we have x squared plus 64. That's the left side. This side simplifies to x squared plus, combine our like terms, 10x plus 25. Right? Would everybody agree this becomes that? If I subtract x squared from both sides, the x squared part drops out, and I'm left with 64 equals 10x plus 25. Which is really nice. I don't have to use quadratic formula, I don't have to factor, I don't have to do any of that stuff. Alright? I'm going to subtract 25 now. So 64 minus 25 is 39. That equals 10x. When I divide by 10, x ends up being 3.9 inches in this case, because it does have units. Did any of our others have units? I didn't even look. No, they did not. Okay. Alright, so that's that one. Number 5, perimeter of the triangle. This is actually pretty easy. You may recall if two tangents... Ooh, that's a terrible circle. If two tangents are tangent to the same circle and they meet outside the circle, then those two segments must be the same length. So basically, if this is 9, so's this. If this is 15, so's this one. And if this is 22, so's this one. And I hope you know how to find perimeter. You're just going to add up all the sides. So basically, we're just going to add them all up. So we're going to have 9 plus 15 plus 15 plus 22 plus 22 plus 9. I guess I can write that out. So basically, there are 2 9s and 2 22s and 2 15s. You should get a perimeter of 92 centimeters. Okay. Again, not a lot of complex calculating. It's really just a matter of figuring out what you're supposed to do. Two circles shown are congruent, which means their radii are equal. What arcs and chords are congruent? Well, first off, I know that arc QR is congruent to the other one that's marked, arc JK. But here's the catch. Because we have vertical angles, I also know that that means those two are congruent as well. Okay? We know the central angle is congruent if the arc that it makes is congruent as well. So you can also say they're congruent to ST and also to ML. We can also say not only are the arcs, but the chords are as well. Chord QR, which is really just a segment. JK, which is a segment. ST and ML as well. Basically, maybe I should highlight those in red. These are the chords that are congruent. Here, I'll change the color so you can kind of see them. Okay? The red ones are there, and you know what the blue ones look like. You could also say something about arc RT, QS, JM, and KL. They would also be congruent as well, but this really would suffice. I'm going to guess that the question on your test will probably ask which of the following is not true or something. So they might say arc RT is congruent to arc QR or something. You know, it should be pretty obvious which is not true. Okay. Find the value of x in the following circles. Well, we have to remember a couple theorems here. Namely, if we have two chords that are marked as congruent, which they clearly are, this is 15, so that means all these are 15. And that means they're also the same distance apart. Okay, so if they were to ask, that would be 13 as well. But anyway, they ask for x. Well, x is both of, it's that whole chord, so it's both of those pieces together, which is 30. You just take 15 plus 15. Okay. Same principle here. If these two chords are congruent, then that means they are the same distance away from the center. So that means x equals 8. Again, not a lot of complex calculating. These are like questions that take literally 5 seconds to answer. Like this one. This whole chord is 25. I notice they're the same distance away from the center. So that means, oh, maybe I should mark that with 2. That means that this whole chord has to be 25 as well. Okay? X appears to be just one piece of that. So we have to do a little math. You have to take half of 25, which is just 12.5. X ends up being 12.5. Whew, we divided by 2. Oh, man. Okay. Number 8, I love 8, because 8 you kind of have to redraw. Again, since this is a diameter, I know that it bisects that chord since it's perpendicular to it. Let me redraw the radius. Oop, maybe I should make it look better. Okay, that is also x. And I happen to know that this is 10 because it's half of 20, right? So I actually have a right triangle. Let me extrapolate that for you. We have 4, we have 10, and we have x. Once again, Pythagorean Theorem comes into play. The hypotenuse is x, so we'll go with 4 squared plus 10 squared equals x squared. We have 16 plus 100 equals x squared, which means x squared equals 116. It tells us nearest tenth, so we're actually going to take the square root of that. Square root of 116 ends up being 10.8 when we round to the nearest tenth. Okay, yay, Pythagorean Theorem. Number 9, I think we'll make this last one in this video. X is this whole chord, right? Things can get really messy. Obviously, I'm going to have a right triangle, so of course I'm going to need Pythagorean Theorem, right? But I could call this x over 2, but I think that'll be really messy when we start squaring things. I'm going to call this y for now, or you could call it z, or you could call it whatever. But basically, when I find y, that's 1/2 of x. So basically, I'm going to have to double my answer for y in order to get x, right? 2y would end up equaling x. So let's do it this way. Y squared plus 6 squared equals 9 squared. Y squared plus 36 equals 81. Y squared ends up equaling 45. And then you take the square root, and it ends up being 6.7. But we're not done yet. That's just this part, 6.7. But basically there's another 6.7 over here. So x ends up being twice 6.7, and you get 13.4 for x, okay? So we had to do a little bit of extra work, but anyway, that's not too bad. That's pretty much it for this video. If you have any other questions, you can always tweet me, leave a comment on this video, or email me. As always, I will be here in the morning to assist you, all right? Good luck studying. I want you to do well on this test, all right? Take care.